Alright then, so this is a very simple problem that is asking us to calculate the distance between these 2 points while using the Manhattan and Chebyshev distances. So the whole point is quite simple actually. We only really have to find distances. So let us go over it. Right, so Manhattan distance. Right, so this one is quite simple. The idea here is that using Manhattan distance, you are going to find the sort of sum of the absolute differences of the coordinate axis. Now that might not make sense, but in simple terms, the sort of distance is going to be something like this. So this is literally what it is. So you will simply find the difference between the x coordinate, consider the absolute value because there's a modulus, and you're going to find the difference between the y coordinates, take a modulus of that and literally sum them up. So let us see how that will be done here. So point A, let us consider it to be 0, 3, and let point B be 5, 8. So the distance is going to come out to be 0 minus 3, 0 minus 5, let's write that properly, summed up with 3 minus 8. That is all it is. So it will come out to be 5 plus 5, which is 10. So that is the Manhattan distance. Now just to give you a sense of how this is sort of being considered graphically, if you have the coordinate axis like this, let me look at what the points were again, 0, 3 and 5, 8. I mean, it doesn't really matter. I'm sort of just going to show you how it is measured. So let us say if you have a point here and if you have a point there, let me remove these other points that we have. So if you have these 2 points, generally the Euclidean distance is sort of just going to measure this diagonal gap between them, the shortest path, right? It will directly sort of find the distance. This is Euclidean distance. Now Manhattan distance does not do this. What it does is that it follows, like it goes step by step towards the point. So it will take these sort of steps parallel to the coordinate axis. That is how it moves. It does not just move diagonally. Okay, so you'll notice that the first steps here that we have taken are parallel to the x-axis, and these steps that we have taken later are parallel to the y-axis. So that is simply how it works, and this is the Manhattan distance. Now let us move to the Chebyshev distance. Chebyshev, now don't worry, I'm not actually going to write the whole thing, but the idea here is also quite simple. So the distance here is simply going to be the maximum of, so it is simply the maximum distance from the coordinate axis in a sense, right? So you would simply write it as, I think, xi max I, xi yi. I think it is something like this, where the idea is quite simple. So again, the points were, I think, 0, 3 and B was 5, 8. So it is very simple. So what we are supposed to do is we are supposed to find the maximum of 0 minus 5 and 3 minus 8, right? So if you actually calculate it, you're going to get 5 well, this is also going to turn out to be 5, negative 5, but again we'll consider the absolute values only. So that becomes 5, 5. So we have to just find the maximum value between the two. Now maximum in 5 and 5 is sort of 5 only. So the Chebyshev distance is going to come out to be 5. Now how does that actually look when we go back to that coordinate axis example? Hold on. So yeah, if we consider that, now here it is not very clear since both the points are kind of equidistant from each sort of axis in a sense. So let me take a very wild example. So what if you have something like this, right? So you have a point here and you have a point there. Now if you only look at how many steps you'll have to take along the x-axis, you have to move from here to around there, right? And then from the y-axis you have to move from somewhere over here to this very long distance over here. So which of these is maximum? Of course it is the distance that you'll have to travel parallel to the y-axis. So that is exactly what Chebyshev is. So that is basically how you find these distances, right? So these are used quite a lot when you have to calculate heuristics and in other algorithms. So it's important that you know these things, and that is basically about it. So here we found out that the Manhattan distance was 10 units and the Chebyshev distance was 5 units. So that's about it.